So it's basically improper. Hanji, बताएं.
Yes, ma'am. So calculating definite integrals at infinity.
When the limit of integration is infinite, then that type of integral is called integral, improper integral of type 1. So basically this improper integral is an extension to the definite integral, and in this extension basically the limit of integration is infinite, or the integrand becomes infinite at the limit of integration or between the interval of integration. So in the first case, when that is in the type 1, the limit of integration is infinite, so it means the region extends towards the x-axis, because x approaches to infinity, or x-axis is the asymptote, horizontal asymptote to the curve. So how we will extend this? We will evaluate improper integral of type 1 by taking the limit to this indefinite through the definite integral. So now we will move towards the improper integral of type 2. Improper integral of type 2 means that is, if your integrand become infinite at the point b, at the limits of integration, that is if it becomes infinite at the point b, then we will replace b with t and take the limit t approaches to b minus b from the left side, and then evaluate this limit, and then we will see what type of integral, then apply the limit. This region becomes this. This is my line, this is my a, this is b, and this is a curve y is equal to f of x, and this curve is basically, this line is basically asymptote to this curve, x is equal to b. This region extends vertically, and if my integrand becomes infinite at the point a, then I will extend it as t by taking limit t approaches to a from the right hand side. Here t is approaching b from the left hand point, and over here for the second case I have this shape. This is my point b, this is the line x is equal to a, this is the interval. Yes. Now t is approaching to a from the right hand side, from the positive side of a. Okay, so this is the second case of type 2, and the third case is, these two are improper integral of type 2. This is the first case, this is the second case, and the third case is when this integrand, this curve becomes infinite at the point c between a and b. So in that case I will break this interval into two parts, split the interval integrand, and c to b f of x dx. Here this line x is equal to c is the vertical asymptote, and this region extends towards the vertically. So this would be extended as limit a to t, t approaches to c from the left side, f dx plus limit t approaches to c from the right side. We will break this interval into two parts. First from A to C, and then t approaches to C, and then from C to B, and then t approaches to C from the right hand side. Right? This is how you will integrate this. So these three cases are the improper integrals of type 2. Yes. जी
इस तरह से भी हो सकता है ना कि दोनों एंड पॉइंट्स पे वो इंफिनिटी को अप्रोच करे
दोनों एंड पॉइंट्स पे भी हो सकते हैं, दोनों एंड पॉइंट पे भी हो सकते हैं, तो उसको भी हम कर सकते हैं। दोनों एंड पॉइंट पे होंगे तो आप दोनों को उसको अलग अलग लिख लेंगे, किसी एक पॉइंट से ब्रेक कर लेंगे फिर, ठीक है। जैसे कि आपके पास अगर ये सिचुएशन हो, इस तरीके से आपका कर्व बन रहा हो, कुछ एसिम्पटोट शो करना जरूरी है दोनों एंड पॉइंट के ऊपर। ये वाला ग्राफ लेना, टू बी है अगर ये, this is A, so how will I write it as a limit?
सर पहले मैम पहले ए से मिड पॉइंट है, यहाँ पे स्प्लिट करेंगे।
Mid point, we can take any point between A and B. We can take any point between A and B. So we will prefer 0. If 0 lies between this interval, we will prefer 0. Otherwise, we can take any point C between A and B, and we will split it at C, split the, and then we can write it as limit t approaches to A minus A to C, and the other one as limit, this is t, this is A plus, limit C to t approaches to B from the left. We would expand it this way. Okay. We have just splitted this integrand to avoid this limit, कि हम सिर्फ एक सिंगल लिमिट लिखना चाह रहे हैं, दोनों के लिए अलग अलग, अदरवाइज फिर हमें डबल डबल लिमिट लिखनी पड़ेगी, वो फिर आपके लिए कंफ्यूजन होगी। ओके, तो आप इसको इस तरीके से भी कर सकते हैं। नाउ एग्जांपल 5, example 5 is you have to integrate this integral, this function. So basically the improper integral of type 2 seems like a definite integral, but actually they are not definite integral. They becomes infinite at some point between, on the limit of integration, or between the limit of integration, between the limit. So this function becomes infinite at x is equal to 2, that is at this point. So I will write, so this x is equal to 2 is the vertical asymptote. So I will write, replace this 2 with t, and then take the limit t approaches to t plus. Then I will integrate this function with respect to x by using power rule, applying the power rule, simply power minus 1 over 2 plus 1, and divide with the same power. And then after putting the limit, that is 5 minus 2, which is 3, and then limit of integration, I will apply this limit, that is t approaches to 2 plus. When I put t equal to 2 over here, I will get 0. This becomes 0. So my answer is 2 under root 3. So it means the limit of this integral exists. The area, or the area under this curve, is finite, or this integral is convergent. These three statements are equivalent. What are these three statements? The first statement is, that is this integral, the limit of this integral exists because it is not finite and infinite. The area under this curve is finite, this integral is convergent. So if I draw this curve, this is the curve and I have to integrate it from 2 to 5, and this area extends vertically, extends vertically. So this seems to be a infinite region, but the area of this infinite region is finite, which is equal to 2 over 2 into under root 3. Right? This is how you will solve it. Now, what about this one? What about this integral? Now, secant of x at 0 is, it is 1 over
1.
cos of x, which is 1. Secant of x at x is equal to pi by 2 is infinite. It is infinity. So it means this function has an infinite discontinuity at x is equal to pi by 2. So I will break this interval 0 to pi by 2. This I will replace this pi by 2 with t. T approaches to pi by 2 from the left side. And then I will evaluate secant of x integral. The integral of secant of x is over here. This is t, not x. So the integral of secant of x is ln of secant x plus tan x, and the limit of integration are 2 and 0. Putting the limit of integration, I will get this answer. Ln of 1 is 0. So when I put this limit, t approaches to pi by 2, this t approaches to pi by 2, both of these are infinity. So my answer is infinite. Infinite. So since the limit of this integral does not exist, so the area under this curve is infinite, or the improper integral is divergent. Right? These are the same questions or the same statements. Now this question. Evaluate this integral if possible. So first we will check whether this function exists for all values on the interval 0 to 3. So this in function 1 over x minus 1 becomes infinite at x is equal to 1. So this function has a vertical asymptote at x is equal to 1. So what will I do? I will break this at 1, this integrand at 1. And then apply the limit t approaches to, it is from 0 to t approaches to 1 from the left hand side. t3 1 over x minus 1 dx, t approaches to 1 from the right hand side. Now integrate this one by one. First I will integrate the first integral from 0 to 1. dx over x minus 1 is, integration of this is ln of x minus 1 mod. So after putting the limit, I will get this answer. When I put 0 over here as the limit, I will get ln of minus 1. Since I have to take the mod, so I will consider its mod, that is ln of 1, which is equal to 0. When I take ln of mod t minus 1, it means t approaches to 1 from the value smaller than 1 from the left hand side. That is values of t smaller than 1. So it means t minus 1 is less than 0 or greater than 0.
Less than 0.
Less than 0.
Less than 0. So I have to, when I am taking the mod, I will write it as 1 minus t, not t minus 1, so that it becomes positive, because t is less than 1. T is approaching to 1 from the left hand side. So I will write ln of 1 minus t. When I take the limit, t approaches to 1, this becomes 1 minus 1, 0. So ln of 0 is infinite minus infinity. If you know the graph of ln, it is like this. This is 1 and 0, it is approaches to minus infinity. So the limit of this integral does not exist. This is infinite. So we don't need to integrate the other integral because whether it would be finite or infinite, when it is added to some infinite number, the whole number becomes infinite. So my integral diverges. So this integral is diverges because one of its component diverges, that is this. जो आपने इसको prove कर लिया तो second one को you don't need to prove the other integral to be convergent or divergent. But if this integral converges, then you need to prove the other integral to be convergent as well. तब आपने दूसरे को देखना है, लेकिन अगर ये ऑलरेडी डाइवर्जेंट आ रहा है, ऑलरेडी इसकी लिमिट एग्जिस्ट नहीं कर रही, तो दूसरे वाले को जरूरत ही नहीं है आप अपना टाइम वेस्ट करें उसको प्रूव करने के लिए. ओके, दिस इज हाउ यू विल सॉल्व दिस एग्जांपल.
मैम
जी,
मैम ये पॉसिबल कब नहीं होगा, जब इन्फिनिटी होगा इन्फिनिटी होगा.
क्या पॉसिबल नहीं होगा?
आपने कहा था ना कि सॉल्व द इंटीग्रल इफ पॉसिबल, जो क्वेश्चन में था अभी.
पॉसिबल कुछ केसेस में पॉसिबल नहीं भी होगा.
मतलब उसमें इन्फिनिटी ओवर इन्फिनिटी होगी तब पॉसिबल नहीं होगा.
नहीं, मैं अभी आपको बता दूं, जैसे कि e की पावर माइनस एक्स स्क्वायर, वो भी आगे जाके दिखाती हूँ आपको, वो मैं नेक्स्ट एग्जांपल में दिखाती हूँ. अगर हम इसको इस तरीके से सॉल्व करते, इफ वी हैव सॉल्व्ड इट like a definite integral, then we could solve it as like ln of x minus 1 from 0 to 3 and becomes log of 2. But this is a wrong procedure because this integral is divergent. We will not solve it like a definite integral. We have to check whether the function is finite on the whole interval or not. If it is infinite, we will consider it as an improper integral of type 2. If it is finite, if it exists for all values of the interval, then we will integrate it like definite integral. तो आपने इसको इस तरीके से सॉल्व नहीं करना. This is the wrong procedure of solving it. We will solve it this way. Okay जी. Basically the warning is that is you have to decide by looking at this integrand that the function is either at an ordinary definite integral or an improper integral. If it is an improper integral, you have to solve it by taking the limit of the integral. Okay, what about this one? Ln of x becomes infinite at x is equal to 0. So I will write it. Replace 0 with t. Limit t approaches to 0 from the right hand. Ln of x. Now how will I integrate ln of x? How to integrate ln of x? Integration by parts. Integration by parts simply like this, and then put the limit of integration which are from t to 1. Now I have to take the limit of this. T approaches to 0 plus. What about the limit? What about this limit? This becomes 0 as t approaches to 0. This is constant. What about this one? 0 into
0
minus infinity. So I will write it as 0 over 0 form or infinity over infinity form. How can I write it? I can write it as ln of t over 1 over t. This is minus. Now ln of t when t0 is infinity and 1 over t when t0 is infinity. This is infinity over infinity form with minus 1 because it remains the same. Now I can apply the L'Hopital rule. When I apply the L'Hopital rule, that is I have to differentiate my denominator and numerator separately. Derivative of ln of t with respect to t is 1 over t and derivative of 1 over t is minus 1 over t square. So I will get, after simplifying, I will get minus t, and when t approaches to 0, the limit of minus t is 0. So the answer is minus 1. So the limit of this function this integrand exists. This is my function. If I have to draw the curve y is equal to ln of x, this is the curve y is equal to ln of x, this, and I have to integrate it from 0 to 1. So this region extend towards the, basically extend towards the negative y-axis. Y-axis is the asymptote to this curve. This seems to be infinite region, but the area of this infinite region is finite, which is equal to 1. And we have calculated it by considering it, by taking it as an improper integral of type 2. Okay, got the points? All of you have got these things? So improper integral of type 2 में आपको चेक करना होगा कि आपका इंटेग्रेंड या आपका फंक्शन कहीं इनफाइनाइट नहीं हो रहा विद इन द लिमिट्स ऑफ इंटीग्रेशन. अगर इनफाइनाइट हो रहा है then break that your integral and then solve it by taking the limit. Okay ji, now I will explain you for the comparison theorem. Sometimes it is impossible to find the exact value of an improper integral, and yet it is important to know whether it is convergent or divergent, because sometimes we don't need to actually find the exact value of an improper integral. For example, this integral, we all of you know that this integral, it is impossible to integrate this integral, this function, and but we have approximated. If this integral is convergent, then this approximated value of this integral makes some sense. Otherwise we don't, if this integral is divergent, we don't need to approximate it. इनफाइनाइट की तो कोई अप्रोक्सीमेशन नहीं होती. तो बेसिकली कुछ केसेस में जहाँ पे फंक्शन को हम इंटीग्रेट नहीं कर सकते लेकिन हमें उनकी अप्रोक्सीमेशन करनी होती है, तो उसके लिए इट्स नेसेसरी to check whether the integral is divergent or convergent. If it is convergent, then we will approximate the integral value. Otherwise, if it is divergent, then we don't require to find this value, approximated value, right? So that's my point. कि आपने इस इंटरवल को जब भी आपको बेसिकली एग्जैक्ट, जरूरी नहीं कि आप एरिया की वैल्यू ही फाइंड करें, आपको ये भी देखना होगा क्या एरिया फाइनाइट आ रहा है या इनफाइनाइट आ रहा है. तो इसके लिए ये थ्योरम है. Now I have two functions f and g. One is f is the top function, g is the bottom function. F is the greater function, g is the smaller function. And what will I do? If I have two integral from a to infinity and from g, integral g from a to infinity. Now, if my top function is convergent, if this is convergent, if the integral of the top function is convergent, what about the integral of the bottom function? Is it convergent or divergent? Can you say anything about it?
Yes, ma'am, it is
Convergent.
also convergent.
Why it's convergent?
Ma'am, nature is the same, I believe.
Nature तो same नहीं है, because if the area under the top function is finite, तो इसके नीचे मैं जो भी function लूंगी, then the area under the bottom function is also finite. It must be finite. So if the integral of the top function is convergent, it means the integral of the bottom function is also convergent. And so if the top function is, the bottom function is divergent, what about the top function, integral of the top function?
It is also divergent.
It is also divergent. So if means if the integral of the bottom function is divergent, the integral of the top function is also divergent. So this is the result of the comparison theorem. So there are two more cases. What are those two cases? There are four cases. The first case is if the integral of f is convergent, then integral of g is convergent. The second case is if the integral g is divergent, then integral of f is divergent. What are the other two cases?
And f is divergent. And g is
Yes, if the integral f is divergent, it does not imply that the integral g is divergent. Integral g may or may not divergent. And the fourth case is if the integral g is convergent, integral f may or may not convergent. That is these two cases. ठीक है? Let's see some examples. Show that e की power minus x square dx from 0 to infinity is convergent. So we don't need to expand it. Basically, if we can expand e power minus x square 0 to t approaches to infinity. So I am unable to integrate this. So what will I do? I will not do this procedure because I am unable to do this integration. So I will just simply check whether this area under this curve is finite or infinite. That is, this integral is convergent or divergent. So the first step is to I will break this interval into two parts. From 0 to 1, from 1 to infinity, e की power minus x square dx. So this is my definite integral. And this one is improper integral. This definite integral because the area under this curve is finite. So the region under this curve is finite, so the area would also be finite. So I need to check this one, e power minus x square from 1 to infinity, whether it is finite or infinite. How to check it? So first of all, I have to build a function to compare it with e power minus x square. I will build a function to compare it with e power minus x square. How to build it? I have to check this. So first I will see that since x is greater than equal to 1, if I multiply it with x square, with x on both sides, the inequality remains unchanged. And if I multiply it with minus, the inequality is reversed. So since exponential function is an increasing function, exponential increasing function hota hai. So when minus x square is less than equal to minus x, so it means e power minus x square is less than equal to e power minus x. So I have constructed a function e power minus x such that e power minus x square is less than equal to e power minus x. Now let's check what is the integration of e power minus x dx. Integration of this is an improper integral. T approaches to infinity. 1 to t e power minus x dx is equal to limit t approaches to infinity minus e power minus x from t to 1. This is limit t approaches to infinity minus, you can write it as e power minus 1 minus e power minus t. This approaches to 0 when t approaches to infinity. So my answer is e power minus 1. Is it finite number or infinite number?
Ma'am,
Finite. So it means this integral is convergent. This integral converges. Since this e power minus x square is less than equal to e power minus x, and this integral is convergent, so this implies that the integral 1 to infinity e power minus x square dx is also convergent by comparison theorem. ओके तो ये जो फंक्शन है ये खुद बिल्ड करना है, ये जो फंक्शन ई पावर माइनस एक्स है ये आपने खुद बिल्ड करना है, और आपने इसको इस तरीके से बिल्ड करना है कि आपका ये फंक्शन ये ना हो कि अगर ये फंक्शन डाइवर्जेंट आ रहे तो फिर आप कोई रिजल्ट डिड्यूस नहीं कर सकते। तो इसको कन्वर्जेंट जबरदस्ती नहीं करना, लेकिन अगर ये डाइवर्जेंट आ रहा हो तो फिर आपने कोई और फंक्शन बिल्ड करना है जिससे ये लेस देन आ रहा हो और वो फंक्शन कन्वर्जेंट हो, या कोई ऐसा फंक्शन जिससे ये बड़ा आ रहा हो और वो डाइवर्जेंट हो, कोई इस तरीके से करना है। 1 टू इन्फिनिटी कन्वर्जेंट आ गया और दोनों सम के इक्वल हैं, ये कन्वर्जेंट आ गया। So this is a definite integral, it is also convergent. The sum of two convergent function is also convergent. Integral is. So on the whole, the given integral is convergent, right? And if you look at it graphically, you will see that this is the situation. Why I have broken the function at x is equal to 1? Why I have broken this integral over at x is equal to 1? जी क्या वजह, क्यों मैंने ब्रेक किया इसको x is equal to 1 पे?
क्योंकि मैम दोनों आपस में कोलाइड कर रहे थे फंक्शंस।
बेसिकली हमें ग्राफिकली तो नहीं, ये तो ग्राफिकली तो ये कुछ जो हमारे पास एक्स्ट्रा इन्फॉर्मेशन थी उससे हमने ग्राफ प्लॉट कर लिया, यहाँ से देखकर तो नहीं पता चलेगा ना कि ये कोलाइड कर रहे हैं या नहीं, लेकिन जो हमें पता चल रहा है वो यहाँ से पता चल रहा है, ये x ग्रेटर देन 1 होगा तो ही जब हमने उसको स्क्वायर किया तो ये ग्रेटर देन x आया, दोनों को x से मल्टीप्लाई किया तो इनइक्वालिटी रिवर्स नहीं होगी, अगर x ग्रेटर देन 1 होगा तो ही। ठीक है, तो इसको आपने ध्यान के साथ इसका यूज करना है कि कहाँ पे इसको ब्रेक करना है। ओके जी, एग्जांपल्स कुछ और भी एक्सरसाइज की मैंने यहाँ पे लिखी हैं, ये भी देख लेते हैं। Now I have this function 1 plus e power minus x over x divergent by using the comparison test. So exponential is always a positive function. This number is always positive. जो भी number होगा यहाँ पे it is always greater than 0. When I add a number greater than 0 to 1, it is always greater than 1. तो यहाँ पे ये number 1 से बड़ा ही होगा. So if I divide it with x, since x is greater than 1, so the inequality remains unchanged. So this interval 1 to infinity 1 over x dx is convergent or divergent? We have seen that this is divergent. So this implies that this integral is also divergent. Okay.
सिर्फ हमने एक का बीच चेक की है, अगर एक मतलब अभी तो हमने सिर्फ 1 और x को ही चेक की है, अगर इसके बाद और इक्वेशन चेक नहीं करेंगे।
क्या क्वेश्चन है आपका?
आपने कहा था कि पहले एक इक्वेशन चेक करो, अगर उससे कन्वर्जन नहीं है फिर अगले पे आओ। अभी तो हमने सिर्फ एक चेक किया है, तो ये क्यों?
तो उससे हमारा रिजल्ट बन गया ना, एक इक्वेशन से ही करेंगे, अगर उससे रिजल्ट रिड्यूस हो गया तो फिर आप फर्दर आगे नहीं जाएंगे।
हो गया मैम।
ठीक है, तो अगर एक से ही करेंगे उसको प्रूव। अगर आपने इस तरह का फंक्शन बिल्ड किया जिससे केस 3 और केस 4 आ रहा है तब आपको अपना फंक्शन चेंज करना होगा, क्योंकि उससे हम रिजल्ट डिड्यूस नहीं कर सकते। ठीक है,
हाँ सही है मैम।
now solve this question, question number 1, this one, 1 to infinity sine square of x over x square. First, you have to build a function. Now, both of these two functions need to be greater than 0. जो भी function आप compare कर रहे हैं वो x axis से above lie करने चाहिए. Now, sine square of x is greater than equal to, sorry, it is less than equal to what?
1.
Ma'am, 1.
1
1.
and greater than equal to 0. Sin x lies between -1 and 1, but sine square x lies between 0 and 1. So I have constructed this one. Sine square x is less than equal to 1. So if I divide it with x square, where x is greater than 1, then the inequality remains unchanged. Then this inequality holds.
Yes, ma'am.
Now, what about this 1 over x square dx? What about this integral? We have seen that for x is for p is equal to greater than
Convergent.
1,
Convergent.
this integral is
Convergent.
convergent. And since sine square x over x square is less than equal to 1 over x square, this is my top function, and top function, integral top function is convergent. So this implies that 1 to infinity sine square of x square dx is also convergent. These two limits should be same. This limit should be same. Okay. So basically this is the procedure. That is, you, in order to check whether the given improper integral is convergent or divergent, you compare it with some function whose integral is, whose convergence or divergence is known to you. known होगी तो ही आप उसको लेके चलें. जैसे इसकी known थी, you have compared it with a function sin square of x over x square whose convergence or divergence is known to you. Then you proceed further. Then you can apply the comparison theorem. Now what about the second one? जल्दी से पूछ सकते जी.
मैम हमने 1 ओवर x स्क्वायर की कन्वर्जेंस को प्रूव किया था पिछले लेक्चर में, तो इसके अंदर हम उसे एज अ रिजल्ट यूज कर सकते हैं.
बिल्कुल एज अ रिजल्ट आप इसको यूज कर सकते हैं. आप यहाँ लिखेंगे कि सिंस dx over x power p from 1 to infinity is, वही जो रिजल्ट पीछे लिखा है, is convergent for p greater than 1 and it is divergent. और ये रिजल्ट मैंने आपको इसलिए कहा था कि ये this example is important because this example would be applied to prove the convergent or divergent of the other integrals. Then you will use this result. You will use this result as it is. You will write this result as it is and then apply it to this. Okay.
Yes, ma'am.
Okay, ji student. What about the second one? What about the second exercise? Exercise 2. This is 1. 1 over ln of x. What is the relationship between ln of x and x? Equal to or less than equal to, greater than equal to? This is my graph. Y is equal to x. This is the graph of y is equal to e power x. And since y is equal to ln of x is the inverse function of y is equal to e power x, so when graphically means that I have to reflect it above the line y is equal to x. तो इसको reflect करेंगे. ये y is equal to x serve as a mirror. ये है y is equal to ln of x. तो ln of x देखें, y is equal to line x के नीचे लाई कर रहा है ना.
Yes, ma'am.
Y is equal.
ln of x is less than x.
So this is ln of x is less than x. और since x is, मैं ये कहाँ से ले रही हूँ, ये x1 है, मैं इसको ले रही हूँ 2 से. 2 से ऑनवर्ड ले रही हूँ। x is equal to, अगर 1 included होता तो I cannot take the reciprocal. Now I am taking the reciprocal. Taking the reciprocal, the inequality is reversed, so I will get this. 1 over ln of x is greater than 1 over x, right? अगर यहाँ पे x is equal to 1 होता तो मैं ये inequality नहीं अप्लाई कर सकती. क्यों नहीं कर सकती? Because ln of 1 is 0, is infinite. So I can apply it at with x is equal. फिर मुझे कुछ और फंक्शन करना पड़ता है, इसको देखना पड़ता है, अदरवाइज एग्जिस्ट भी ना करता. फिर अब इसको हम प्रॉपर इंटीग्रल की तरह दूसरे तरीके से सॉल्व करते हैं. ओके जी, 1 over ln of x greater than 1 over x. So by again using the result 1 over x dx is convergent or divergent?
Divergent.
So my bottom function, integral of the bottom function is divergent. So this implies that 1 to infinity, sorry, this is 2 to infinity. I can, because if 1 to infinity this integral is divergent, so from 2 to infinity it is also divergent. So 1 to infinity 1 over ln of x is also divergent, right? Any question related to this? This is your last question. Practice questions और भी हैं, or this one is your last question. How will you prove its convergence or divergence? How will you check its convergence or divergence? ये जल्दी से बता दें, टाइम कम है. ये कैसे होगा?
मैम ये कन्वर्जेंट होगा.
कैसे?
मैम वो इसमें इन्फिनिटी पुट करेंगे तो इसका आंसर 0 आएगा.
आपने इसको यहाँ पे ये नहीं लिखा कि आपने इसको इंटीग्रेट करना है. यू हैव टू यूज कंपैरिजन टेस्ट टू डिटरमिन इफ द इंटीग्रल इज कन्वर्जेंट और डाइवर्जेंट.
मैम ये कर सकते हैं कि इसको जो ये पार्शियल फ्रैक्शन अप्लाई कर दे इसमें.
पार्शियल फ्रैक्शन तो तब करेंगे जब हमने इंटीग्रल को एवेलुएट करना हो. हमने बगैर एवेलुएशन के ही इसको कन्वर्जेंट या डाइवर्जेंट प्रूव करना है. कंपैरिजन थ्योरम अप्लाई करना है. ये कंपैरिजन टेस्ट लिखा हुआ है ना, फिर आप एवेलुएट नहीं कर सकते इसको. कंपैरिजन थ्योरम ही अप्लाई करना है. इसको कंपेयर करना है किसी फंक्शन के साथ जिसकी कन्वर्जेंस या डाइवर्जेंस उसके इंटीग्रल की नोन हो. You have to compare it with some function whose convergence or divergence is known to you. So first I will build that function. How? z4 plus 2z square is greater than z4. Is it greater than z4? Because z is greater than 1, so I will add some positive number to z4, which is always greater than z4. So when I take the reciprocal, I can take the reciprocal because this is not equal to, both of these two numbers are non-negative, they cannot be equal to 0, so I can take the reciprocal. I can write it as this way. Now what next? फर्दर क्या करेंगे आप? हमें तो z -1 चाहिए ऊपर, तो पहले z लगा लेते हैं. I will multiply both with z. The inequality remains unaffected. Okay. And what about z -1? क्वेश्चन तो मेरा z -1 है. What about z -1?
मैम
Since z
दोनों
over
साइड पे
z4, दोनों साइड पे नहीं करेंगे, because z over z4 plus 2z square is already less than z over z4. So if I subtract it -1 from it, inequality remains unchanged now. तो उसमें से सब्ट्रैक्ट कर लें, इनइक्वालिटी पे कोई फर्क तो नहीं पड़ेगा ना, वो तो लेस देन और लेस देन हो जाएगा, लेकिन ग्रेटर देन तो नहीं होगा ना. So I can write it like this. Now this is my 1 over z cube and integral 1 over z cube dz converges. This is my top function.
Conversion.
So this implies that 1 to infinity z minus 1 z4 plus 2z square dc also converges. Okay. Any question related to this? No question?